Welcome to the Blue Security Podcast, a weekly podcast for information security defenders, where we bring you discussions on best practices, tools, and implementation for enterprise security. Now, here are your hosts for today's show, Andy Jha and Adam Brewer.
Welcome to another episode of the Blue Security Podcast. I'm Andy, your host.
I'm Adam, your co-host. And by the way, as Andy and I frequently mention on this show, we both are employed by Microsoft. This show is not sponsored by Microsoft. Microsoft does not have any editorial control over the show, but we do find it important to mention that, especially when we're covering technologies that Microsoft offers in the marketplace, which we'll do a bit of tonight. And so on that note, we cover Microsoft a lot on this show, and maybe part of the reason why is because we're familiar with it. It is our day job. It's something we know. We intend to be educational about it. We're going to educate you on features and capabilities. Obviously, make your own decision. There's a lot of competitors in this space, Wiz and Palo Alto, to name a few. And so, of course, we encourage our listeners to do your due diligence and pick the vendor that's right for you. We're just here to educate and share what we know. And oftentimes that's what we do in our day jobs. With all that said, Andy, it sounds like tonight our topic is containers, which is something I'm definitely interested in learning more about because they always seem like a little bit of voodoo to me in how they kind of magically work. So I'm excited to dig into containers and how we secure them.
Yeah, absolutely. Containers, I want to do a little bit of Containers 101 for those who might not know what containers are and how they work. And then we'll talk about how to secure them. But containers have been around for a while. Most of the time when we talk about containers, it's cloud containers, but they can actually be hosted on-prem as well. And they're basically software code packages. And what they do is they contain all of the application's code and libraries and dependencies that it needs to run in one tiny container. And so anytime you have software code, there's always additional files that are required to run it. You know, sometimes you might get something that pops up like your net is out of date or your C++ library or something like that when you're running something and you're like, oh, I need to install something else. And so those libraries and dependencies are required to run that program and be installed on that machine, usually your host machine, before it can run. And each operating system that you're running the software in, that software has to be packaged differently. So if you're running it in Windows, if you're running it in Mac or Linux or on a mobile operating system like iOS or Android, that software is packaged differently and those libraries and dependencies are installed differently. And so with these containers, it just packages all of that in one tiny little thing and into a single file that can run anywhere. When we talk about containers, a lot of times, when it comes to virtualization, a lot of people think VMs, virtual machines. And virtualization can actually take place in a lot of different forms, containers being one of those. But what is the main difference between a VM and a container? Because I think a lot of people really understand what a VM is. At a high level, VMs virtualize like the underlying host hardware into, a multiple different ways, like operating systems that can run on that hardware. And each VM has an operating system and has access to virtualized resources representing that hardware. So pretty easy to understand if you've ever deployed a VM. If you have a host, physical host that has 128 gigs of RAM, 64 terabytes of storage, so on and so forth, 24 physical cores on your CPU, you can divide that resource into a VM. So a VM might have 4 cores and 16 gigs of RAM and, maybe 1 terabyte of storage. So it's taking that and it's setting it aside. And when that VM is running, it's using that resource to run that VM. A container virtualizes the underlying OS. It obfuscates it. And it containerizes the app to perceive that it has an operating system, which includes CPU, memory, file storage, network connections, all within the container itself. And so the difference is that the underlying OS and infrastructure are obfuscated and abstracted as long as that base image of the host stays the same, the host operating system. So it can run anywhere as long as you take that container and move it around. And when I say it can be run anywhere, sometimes, well, you do need to, of course, compile it differently for the different operating systems. But when you move it from host to host, as long as the underlying OS doesn't change, you can still run it anywhere. And so the containers themselves, they share an operating system, unlike a VM, which actually has its own operating system within the VM. Containers share the underlying operating system. And so they don't need to boot into an operating system. They don't need to load any libraries. And so they're much more efficient and lightweight, and they can start in seconds. I can give you a real world example of something that I've done that actually will kind of put this into perspective. So many of you in tech might run something called a Plex server. It's a media movie server. And there are a lot of different ways to run a Plex server. You can run it literally on your desktop or laptop machine as long as you have it connected. You can install the application called Plex server and run it. And then you have your files hosted locally within that. You can also connect it to a NAS and still do that. I ran it in a VM for a very long time. So I virtualized it and had the Plex app installed on the VM. But with that, I had to continually keep those resources of my host machine running. So it took up resources all the time. And whenever came out with an update, I had to patch the operating system, therefore taking down the application and having downtime. So it was not as stable as I would have liked it. So instead, now I run a Plex container, and the container is super lightweight. And if it ever needs to be updated, it'll pull from the registry, the image, and it'll pull it down and update it. And it takes seconds to update, and I'm up and running again. So literally no downtime, and it runs exactly the same. But instead, I don't have to set aside resources of my physical host in order to run the VM and the guest operating system, the Windows operating system, and then run the app on top of that. I can just run the container. So that has made my life a lot simpler. Hopefully that all made sense. Adam, as someone that might be a little bit newer to or might not understand, did that make sense to you how I explained it?
Yeah, it definitely did. You have all the overhead of that guest operating system and all the care and feeding of it. I think when you got to the real world example with Plex server, that makes a ton of sense where you, and I'm sorry, I got on a tangent for 1 second. When you mentioned you virtualized Plex, I was saying, oh, good, because Plex has famously had many vulnerabilities over the years. So that's at least a better model. But containerizing it is even better, because if somebody breaks into your Plex container, they don't have access to anything but literally what's in the container, which is awesome. So that really did, in terms of, I was thinking like, well, you keep saying share the OS, but when you have a bunch of VMs, like all the VMs are kind of sharing the hardware, but they're not necessarily sharing the OS. They're each individual instances of it. And so that is just less overhead, I think, is how I thought about it. When you think of all of the extra components that an OS has that do all these different things, like when you have a container, it's just what it needs and nothing more. So it's very efficient use of resources, because I'm not spinning up a bunch of libraries or a bunch of services that don't need to be running for what I'm trying to do. And that makes a ton of sense. So yeah, I've always tried to like follow and read about them, but the real world example always helps.
And so when you talk about containers, oftentimes Docker comes up. Docker is essentially a very similar concept to VMs. And what it does is it allows that obfuscation and abstraction of the underlying host operating system. So if you imagine you have your host machine as the bottom layer, in a VM situation, you would have the hypervisor running on top of your physical hardware. And then that would help you virtualize each individual VM, and each individual VM takes up a portion of that physical hardware that has to be set aside for it, as well as each VM is running its own guest operating system. With containers, you have that underlying host physical infrastructure, Then you have your host operating system, let's say Windows in this case, and then you install Docker. Docker helps run those containers. And so the containers sit on top of the Docker, and the Docker helps share that OS essentially. So it's basically instead of having to run an entire operating system, just like a VM for each container, Docker helps you run that container and helps you use that host operating system underneath so that you're only virtualizing the application, the software. Oftentimes also the term Kubernetes comes up. And Kubernetes is actually an open source platform that is designed to deploy, scale, and manage containerized applications. It's used for automation. For example, if like a container goes down and then another container needs to start, it would be easier if that behavior was handled by the system. And so that's what Kubernetes does. It's an orchestration tool that a lot of organizations use, a lot of developers use to help you spin up, spin down. It can help you assign different things, network components, DNS, so on and so forth. So that's what Kubernetes is. It's just an orchestration tool. And then finally, when it comes to containers, you need to understand what container registries are. And container registries are essentially a repo or a collection of repositories, and they're used to store container images. So just like with, say, when you're downloading image of Windows operating system or an image of a Linux server operating system, and then you install that on a VM, containers need an image in order to install on the container so that you can run the application. And so these registries contain the images of these containers that you would pull down. So Plex has a repo that I can, or a registry that I can connect to, and then I pull the container image down and I run the container on my machine. So that container image contains all the files and components that make up that application to run successfully within the container.
One thing I saw, so if you see this, you'll know what it means because I had to look it up. I've often seen Kubernetes shortened as K, like the letter K is in kilo. And then I've seen the numeral 8, and then the letter S is in Sierra. And I always wondered, why is that a shortening of it? Well, what it literally means is the first letter is K in Kubernetes, the last letter is S, and then there's 8 characters in the middle. And so the 8 stands for the 8 letters in the middle, the UBERNETE. I've actually seen this other places now too, so you'll start to run into it. There's a famous venture capital firm in Silicon Valley, Andreessen Horowitz, where Steven Sinofsky, formerly of Microsoft, now works, and they shortened theirs to be, instead of Andreessen Horowitz, which is a pain to spell, they shorten as A13. Anyhow, if you ever see K8S and wonder what that means, it means Kubernetes, and that's how you get that kind of shortening structure, is it's the number of characters in the middle. I had not run into that before. Maybe our listeners are more familiar with it, but now you know.
Yeah, so now that we have a little bit of understanding about what containers are and some of the terminology behind it, more importantly, as security defenders, how do we secure it? Because traditionally, we have run software and enterprise applications on, servers that we've hosted and then moving to the cloud and virtualization, and we're familiar with VMs. And with VMs, we have guest operating systems. And with those, we have the traditional tools that we use, like Defender for Endpoint or any other endpoint detection solution like CrowdStrike or Sophos or whatever, that have server versions, user operating system versions that you can just install just like you do with your physical machines. But containers are not the same way. And so as organizations move to containerize their enterprise software, how do security defenders secure that? Well, with Microsoft, we have a solution called Defender for Containers, which is part of our cloud security offering called Defender for Cloud. And if you've been following along with the cloud security series that we've had, this is basically an extension of that to containers, specifically containers. Back a few years ago, we had something called Defender for Container Registries and then Defender for Kubernetes, which we've now combined into just one single Defender for Container offering. And what it does in a nutshell is essentially it secures your containers in 4 different domains: security posture management, vulnerability assessment, runtime threat protection, and then deployment and monitoring. And so I'm not going to dive too deep into each one of these, but just some high-level keynotes, because again, you can't really install things in the container because it's all designed to run, as we've talked about, just the application and just what it needs. So there is a sensor that we can deploy as part of this solution. It generally monitors things within like your cloud subscription. So this is a cloud agnostic solution. It works for everything from Azure Kubernetes and containers to Amazon's Elastic Kubernetes service, Google Kubernetes engine, and it even works in unmanaged Kubernetes distributions that are Arc enabled and are hosted on-prem or IaaS. And so across the board, it can work. And when you do that, you can either monitor it with a sensor or it can do agentless. With a sensor, it does provide a little bit more capabilities, but there are plenty of capabilities that are available as agentless. And that's really the key here, because it's very hard to, I mean, you're not supposed to really deploy an agent in these containers themselves. So just a couple high level notes on some of the things that it defends against. It allows you to have vulnerability assessment for all of your container images. So if one of the registries becomes corrupt or a hash of an image is reported as malicious and you're pulling it down, this will flag it. And it will also have runtime vulnerability assessments and scans of new images and refreshes of the results daily. It'll give you some exploitable insights, and it'll allow you to have a comprehensive inventory of everything that you have within your resources, your pods, your services, your repositories, your images, your configurations. And with the Microsoft solution, we have something called Security Explorer that you can go and easily monitor and look up and do risk hunting if you want to do that. And there's ways that security admins can also go and proactively hunt for issues in your containerized assets through queries. So with Microsoft, we have KQL or Kusto query, and that's all built in with a bunch of custom or built-in queries, as well as you can craft your own with custom queries. And then you're going to get those security insights within the Security Explorer. One of the things that you do get with the sensor is you get something called binary drift detection. So Defender Containers provides a sensor-based capability that allows you to get alerts on potential security threats by detecting unauthorized external processes within the container. So if somehow the network connections get compromised and then there's some external processes that are running within your containers, we're going to pick those up with that sensor-based capability. You can also monitor alerts and security incidents, such as like if you have an exposed Kubernetes dashboard, you have some creation of high privileged roles or creation of sensitive mounts. And another thing that you can do is Kubernetes data plane hardening, which is again another one of those sensor based capabilities. But there are again a lot of agentless capabilities, and this is extremely easy to deploy. So all you're doing is just like in the same place that you're onboarding your VMs in your Azure subscriptions, your AWS accounts, or your GCP projects, or your Arc enabled machines, your Arc enabled Kubernetes and containers, you're essentially just turning on Defender for Containers. It's just a one-click configuration. You just turn it on. And so there's not infrastructure that you'd have to deploy. It's all just done within the subscription. Either we'll monitor those with a sensor or we'll, do the agentless capabilities for you.
Andy, you and I were talking before the show about our day jobs, as I mentioned in the disclaimer up front. And we were talking about working with some of our peers in our Azure App Innovation and Modernization team. And this is an area where, for our listeners and viewers, you will probably have the most interaction with your own internal IT folks, will be the folks who do a lot of your application development and are creating your modern style applications. They're going to be the ones building containers and wanting to run stuff in containers. Also, you will certainly have third-party containers that you may leverage from time to time as well. So there'll be a good mix, but either way, what they're really concerned about is, I think everyone understands that security is a shared responsibility today, and it's everyone's job. However, they, like everyone else, wants to do their day job. And again, you could argue security is your day job, even if you're an application developer. I get that, but they want to write code. I guess. Let's just get to there. And one of the things that excites them about a solution like this for both our app dev folks as well as our security listeners is this is an basically zero impactful deployment for either one of you. For security teams, it's flip a switch on an Azure subscription, and it's now enabled, as Andy mentioned. And for your folks who are writing code, they don't really need to change anything they're doing. And you can begin to take advantage of this and have that enhanced visibility and posture management and threat protection without really doing a whole lot of work on anyone's part. So that's the really exciting part, is across the board. It's really simple to get started, and you're only paying for what you use. So I think that's why this is easy to test, kick the tires on if it's something you're looking at and you're running more and more containers, which I would imagine is most everyone. So that's really exciting part about this, and just really this is such cool stuff. I just love learning about this. I think the other thing I wanted to say to security teams as I wrap up my segment is, Andy, you were talking about how defenders are very familiar with protecting like a virtual machine, because it's kind of like run the playbook. We're going to install management capabilities on it. We're going to install an endpoint protection platform like a Microsoft or a SentinelOne or a CrowdStrike or a Palo or whomever. And then we're going to monitor the posture of it. We're going to monitor the EDR telemetry coming off of it and do that. And see security teams struggle to adapt to more simple and modern systems when security teams come at mobile devices like an iPhone, and they want to demand the same level of management they have on a Mac or a PC, and are disappointed to learn that's not there. That's actually good news for you. There's less attack surface on those devices because they can't run third-party code as a privileged user at all times with inspection to everything. It benefits you as a security team, but it's also attack surface. And so things that are simpler like this, like containers, sure, you may have less opportunities to really dig into it and dig under the hood and see what's happening, but they're also more secure by the simple fact that they are simpler. There's less there. There's less attack surface there. They're spun up and torn down more frequently. So even if attackers break into them, there's nothing to really get a foothold into if I'm building and destroying containers all the time. They're not really persistent in the same way as like a virtualized operating system is. So, come at this with a fresh set of eyes too. For our defenders out there, sometimes we equate having knobs to turn and levers to pull as something I can secure. And then we look at it with, well, if there aren't knobs to turn and levers to pull, then I can't secure it. And it may just be there's less for you to do there, which again enables you to put your focus elsewhere where it needs to be. So I think that's the other thing to think about with containers. As you were talking through it, Andy, I thought to myself, I bet there are some people who are having a hard time with this because there's really less to do. There's less to look at. There's less to dig into. But I think that's a net positive for security overall in the operating model of these. And yes, you do need to protect them. And that's what we're talking about tonight. It's protecting them in a different way than how we would protect a different use case. So some food for thought as we kind of start to wrap up here.
Yeah, I do think this is a potential blind spot for a lot of security defenders and organizations, because it's just kind of like, oh yeah, the app guys are over there developing their things and we're deploying things, and we only monitor VMs. But how do you know? Like, I deployed this Plex container, and to be honest, I don't have something like this in my own environment, so I don't know when I pull that Plex image down and run it on my server back here. I don't actually know if it's running malicious code. I don't know if it's been compromised. I don't know if there's external processes. And then when you're talking on an enterprise level, you have the Kubernetes orchestration, you have Docker and all that. Like, how do you know that that is configured correctly? And so this gives you a way to like say, oh, you have this particular configuration wrong. You should go and look at that, whatever it is. And I don't know a ton about the different alerts, but assume it's things like, you have external ports or resources exposed, or maybe privileged users or identities are not configured correctly, that you don't have those secured, so on and so forth. So, it gives you actionable insight to go back to that team and say, hey, I'm getting these alerts. let's work on the security posture of the data plane, the orchestration service, as well as those individual container registries and containers themselves.
That's basically perfect, right? If it gives me actionable alerts, even if I'm not an expert in container security today, that gives me something to sink my teeth into. And if I'm a defender, really a way to learn by doing with real world scenarios. And that's super helpful. So this is like putting a expert security defender who knows container security really well, keeping track of everything going on in your environment. And that sounds like a pretty good win.
Yeah. So hopefully you guys take a look at this, contact your Microsoft account team if you're interested. Again, this is a cloud agnostic solution, so it works in all the clouds as well as on-prem. So whatever you have deployed, this will work for it. And, if that doesn't work for you and you want to explore other options, like we said, there are other providers out there that provide this similar capability.
Mm-hmm.
I'm not sure, honestly, how many provide specific container security, because I've looked into it, and this is fairly unique, I think, to Microsoft, but they do have other cloud security solutions. So take a look. Hopefully you find something that meets your needs. That's our show for this week. Hopefully you guys picked up a little bit about how containers worked and how to secure them. Our contact information will be in the show notes if you have any questions or topics you want us to talk about in the future. Thanks. We'll talk to you guys next week.
Thank you for listening to the Blue Security Podcast. Please check out the show notes, catch up on episodes you may have missed, and subscribe so you don't miss any future episodes. Find Andy on Twitter @AJaw0 and Adam @AJ Brewer. See you at our next episode.